Hi there. I'm glad we found a little hush together. The night leans in like velvet, and somewhere beyond the rooftops, the sky is keeping its slow, patient time. Out there, clouds of gas curl into stars, planets circle like lanterns, and whole galaxies wheel with the grace of a tide. Tonight, we'll follow that gentle motion and ask a soft, curious question. Why is everything in the universe spinning? We'll trace the story from tiny ripples in the early cosmos to the twirl of atoms, the turning of worlds, and the great carousel of galaxies. How a whisper of imbalance became a choreography that never quite stops. Nothing hurried, just a quiet drift through causes and clues until the idea feels light enough to carry with you. If this gentle wandering feels right, a quiet like and a soft subscribe. Help others find this calm only when it rings true. The stars are patient, so are we. When you're ready, we'll begin together, unhurried and warm. Have you ever noticed how the world carries you as if on quiet rails? The floor is steady, the cup stays calm, the window holds a slice of sky that seems to wait with you. And yet, beneath that quiet, our home is turning. Near the equator, the skin of Earth slips past at about 1,000 miles each hour, the planet itself circling the sun at roughly 67,000 miles per hour, and the whole family of planets sweeping around the Milky Way at close to 490,000 miles per hour. It sounds like a storm of motion, but it feels like a lullaby. Nothing shivers in the glass. The trees do not lean from a cosmic wind. The stars keep their places, patient as old friends. The contrast can feel like a trick, the universe in a grand whirl, and we, somehow, unruffled. The gentlest explanation is also one of the most faithful. Everything near you is moving together. The body you inhabit, the chair, the air, the walls, the oceans and continents, each belongs to the same smooth turn. To notice motion, there must be a change, a push or a pull that treats one thing differently than another. When a ride begins or ends, when speed rises or falls, when a path curves or straightens, the inner instruments that keep balance speak up. But steady motion, motion that keeps its pace and keeps its direction, has a way of becoming a kind of stillness. It is not that the movement disappears, it is that the movement is shared. This habit of the world has a quiet name: inertia. Long ago it was put into simple words: things keep doing what they are doing, unless something persuades them otherwise. If they rest, they tend to keep resting. If they glide, they tend to keep gliding. In our daily scale, we do feel starts and stops, the gentle nudge when a train pulls away, the soft lean in a turning car, the small weight shift of a bus easing to a halt. Those are changes, and changes are what our senses are tuned to hear. But when a journey smooths out and becomes even, the noticing fades, the tease settles, the mind returns to its own weather. The same idea carries to the largest room we know. Because the spin of the earth is steady, and the air turns with it, and the ground does not lurch, there is no signal to wake alarm. The planet keeps its rhythm, we keep our calm. Consider the ship that crosses a wide sea. On deck, a breeze moves hair and jacket. Below, a book can be read in peace. Or think of an airplane going 500 miles an hour. Inside, the cabin is a small town in the sky. People talk softly, pages turn, someone stirs cream into coffee and watches the spiral fade. What changes the feeling is not the speed but the unevenness, turbulence, A climb, a bank, that is acceleration, and that is what the inner ear knows best. Velocity is a story about how fast and which way. Acceleration is the change in that story. Our balance responds to the change. In orbit, this truth becomes a window. A spacecraft circles Earth at nearly 17,500 miles per hour and loops the planet in about 90 minutes. From the ground, it seems impossible that such speed could be gentle. Inside, it is quiet, no air hissing by, no wheels on tracks, no road rumble, just the soft murmur of machines and voices learning a new sense of down. What keeps everything so serene is that the craft and its crew are falling together. The path curves forever, and the floor that catches each step is also in the fall. When change is absent, motion wears the mask of stillness. A museum has a way to show the hidden turn. In the middle of a hall, a long pendulum swings. It seems to keep one playing forever, a faithful metronome of the air. Yet over the hours, the path slowly rotates. Pins set in a circle are knocked down one by one, not because the pendulum is twisting itself, but because the floor is turning beneath it. This simple instrument, demonstrated in 1851 and repeated in many cities since, is a kind of poem about our situation. We are moving through the dark, and the things we build can catch the movement without leaving the room. The planet's spin is not a small detail. It shapes the day. The line between light and shadow travels across land and water with clockwork patience. Weather listens to this rhythm. The magnetic field, born of a dynamo deep within, leans on rotation to stay alive. In turn, it shields the surface from some of the sun's harsher gifts. Even the length of a day carries a long memory. Over vast ages, tides raised by the moon have been trading energy with Earth's spin, a slow exchange that ever so slightly lengthens the day. The number is modest, about 1.7 milliseconds added to each century's day, but it is a sign that even the most reliable rhythms are breathing in time. When we step from the scale of a planet to the scale of stars, the spinning continues. A star begins in a cloud, gas and dust adrift, cool, patient. A small imbalance invites a collapse. As the cloud draws in, it conserves its turning, the way a dancer spins faster when arms come closer. The center brightens, the disk flattens, and a newborn sun pushes light into the dark. The planets are children of this process, inheriting pieces of the original turn. Our 24-hour day is, in a way, a fossil, a lingering record of a time when the solar system was a wide whirl of dust and ice and aspiration. The sun itself rotates, too, about once every 27 days. At its equator, its magnetic threads winding and unwinding, sometimes tangling into storms that leap into space. Beyond all this, the city of our sky rotates as well. The Milky Way completes a turn in something like 230 million years, carrying hundreds of billions of stars in a slow, spiral drift. It is an ancient waltz, measured not by minutes or seasons, but by passages of life on Earth. When creatures first stepped from the water, the galaxy was at a different angle. When forests spread, it had swung further. When we learned to shape tools and names, the arc continued. And when we point our instruments to the faint and far, we see the same habit written into the earliest structures. Some of the galaxies whose light has traveled more than 13 billion years to reach us show the faint signature of rotation, one edge, just a little redder, the other a touch bluer, suggesting that even when the universe was young, it had already learned to turn. All of this invites a softer question. If everything moves, what do we mean by being at rest? The answer sits quietly inside the idea of relativity. There is no single throne where motion is judged. Every place, every traveler, can claim stillness by measuring from their own seat. On Earth, you can treat the ground as faithful and let the sun cross the sky. On a spaceship, the cabin can be the quiet middle, while the world sweeps beneath like a map. Two stories, both true, because they are told from different frames. The rules of physics keep faith with each storyteller, so long as each tells the tale with care. This way of seeing rescues the calm we feel, without denying the grand currents around us. We are not wrong to call our rooms still. We are simply choosing a frame where the furniture keeps its agreements. From another frame, we become travelers at speed. It is not a contradiction. It is a kindness the universe allows, so that laws remain consistent and experiences remain bearable. Notice, too, how time and turning keep company. A day is one spin, a year is one circle around our star. The seasons are the tilt carried through that circle. The calendars we trust are all bound to motion. If these motions changed wildly, our sense of time would fray. But the steadiness of the spin, the patience of the orbit, the predictable sweep of the galaxy across generations, these are what braid time into something we can lean on. The clock on the wall counts seconds, but its meaning rests on larger wheels, turning without drama. If you look for proof that this quiet motion is real, it is everywhere once you know how to listen. A gyroscope keeps its direction while the world goes around it, a stubborn compass of motion. Satellites must be steered with the planet's turn in mind, and the signals that tie our maps together arrive with tiny corrections that honor both gravity's pull and Earth's rotation. Even the winds know. The great currents that move storms and shape climate bend in response to a turning world, carving patterns into the air that repeat with the grace of a refrain. Nothing about this erases the hush we live inside. It deepens it. The quiet is not emptiness, it is harmony. Countless motions layered so evenly that they make a smooth surface to rest upon. The stillness you notice at midnight is the kind you find at the center of a wheel that never stops. The spokes may blur, the rim may race, but the hub offers a place to be unhurried. There is a comfort in remembering that even slowness is relative. The sun's 27-day spin feels swift compared to the galaxy's long turn. The galaxy's turn feels like eternity compared to a hummingbird's heart. A hummingbird's heart is a blur compared to the patience of rock. Scales nest inside scales, each with its own rhythm, each true in its own domain. We live where those rhythms cross and cancel, where equal motions shared by all become a soft zero that feels like rest. Sometimes people wonder whether the universe itself might have a grand rotation, a slight twist written into space and time from the beginning. The evidence is careful, and the answers are cautious. If such a turn exists, it would be subtle, not the kind of motion that would tug a cup or lean a tree. What matters for our small rooms and ordinary nights is closer. The ancient spin, inherited from the first collapsing clouds, the steadiness kept by conservation of angular momentum, the way uniform motion hides in plain sight, and the way perspective chooses which motion to call home. If it helps, keep a few anchors lightly in mind. Earth rotates once in about 24 hours and moves around the sun at roughly 67,000 miles per hour. Our solar system orbits the center of the Milky Way at close to 490,000 miles per hour, finishing a galactic lap in about 230 million years. The sun turns about once every 27 days, A spacecraft in low Earth orbit circles the planet in about 90 minutes at around 17,500 miles per hour. A pendulum in a quiet hall proves the ground is turning without needing the sky's permission. And, over long ages, the day's length creeps by, about 1.7 milliseconds each century, as tides and rotation trade their tiny favors. These are not burdens to memorize, they are gentle touchstones, small lights in a wide room. When the night is clear, it can feel as if the stars are pinned in place or shifting so slowly that a single breath could never prove it. That, too, belongs to the hush. The sky keeps a pace far larger than a heartbeat. Yet if you return to the same patch of ground season after season, year after year, the motion steps forward. Constellations rise from new doors on the horizon. Old angles lean. Familiar patterns slip to different hours. The long clock speaks in patience, and you grow fluent enough to hear it. Stillness, you learn, is only the feeling of a perfect glide. Time is counted by turns. The room you sit in rides 3 great circles at once. The lamp is an island in a river that never stops. The silence isn't a gap between sounds, but many smooth motions blending into one soft note. Peace doesn't require a halted world. It's the evenness a turning universe has practiced since long before we had names for it. Hold that evenness for a moment and let it open the oldest door. If you could peel back the ages like thin sheets of light and stand within the first flicker after the beginning, there would be no tidy stage, no trumpet of arrival, only heat, brightness, and space unfolding. The questions there are simple and enormous. Was there already a twist in that first breath? Did a small imbalance set everything in motion? No throne answers, no voice explains. The reply lives inside physics, in the way motion begets motion, and a tiny asymmetry, given a vast enough canvas, can grow into the orbits, spirals, and quiet glides we hear as the universe's steady song. At the edge of what our math can currently hold, there is a window with a delicate frame. Cosmologists call it the Planck era, so early that the clock would read about 10 to the power of -43 seconds after the beginning. The rules we use for everyday matter lose their footing here. Gravity and quantum effects both speak at once, and our equations stutter. Yet even across this fog, a few signals drift through. The universe did not wake in perfect smoothness. Tiny irregularities, whispers in temperature, density, and direction were already present, and those whispers became the seed of everything later. We know this because the first light still lingers. Long after the fireball thinned and cooled, a soft afterglow remained, stretching into microwaves as space expanded. That glow, the cosmic microwave background, is a map of the infant universe preserved in radiation. Satellites have traced its faint freckles with patient care, first by missions like WMAP, and later with exquisite detail by ESA's Planck Observatory. Across that map, the differences are small, only millionths of a degree, but they are enough to tell a tale. The early cosmos was not featureless. It had little swells and hollows, like ripples on a pond barely stirred, and those slight imbalances grew into galaxies, stars, planets, and the corners of the night where we live. Among the patterns, some researchers noticed a murmur of something stranger, a suggestion that the most distant ripples might favor a direction, as if the overall fabric had a faint alignment. The nickname was playful and unsettling, the axis of evil, not because it was dark, but because it misbehaved against expectations. If real, such an alignment could hint that the largest scales bear a memory of a preferred orientation, maybe even the faint echo of a global rotation. But the cosmos is a place where measurement itself is delicate. The same data can also be folded into more ordinary explanations: instrumental quirks, statistical flukes, the stubborn fingerprints of foreground dust. Between those possibilities, the conversation remains gentle and cautious, either a subtle artifact we will someday understand, or a sign that the universe, in its widest view, once had a slight sense of this way. How would such a twist be born? Even in emptiness, nature is never perfectly quiet. Quantum fields, the background hum of existence, have an unstill character. They jitter with tiny fluctuations that no hand causes and no switch can silence. When the universe was smaller than an atom, those fluctuations lived everywhere, a kind of restless potential. Then came the rush, the brief, astonishing growth called cosmic inflation, proposed in 1981 by Alan Guth. In less time than we can picture, space stretched by staggering factors, smoothing the overall scene while taking those quantum jitters and pulling them into grander scales. Where there had been a microscopic flicker, there was now a macroscopic nudge laid into the geometry of the newborn sky. In that stretch, a particular kind of pattern could arise, one with a curl, like a tiny eddy in a broad current. Physicists call the curling imprint in spacetime's first waves B modes. If the earliest gravitational waves carried these swirls, they would be a fossil signature of rotational stories in the beginning, proof that the first motions carried more than simple outwardness. Experiments like Bicep 2 once reported hints of such a signal. Later work showed that interstellar dust had crowded into the measurement and complicated the picture. The search did not end. It simply learned to be more careful. Even now, telescopes on high plateaus and satellites above the air refine the listening, trying to separate the whisper from the rustle. A confirmed curl would not be a photograph of the first spin, but it would be a strong nod that the first motions included twists as well as waves. Whatever the precise path, the universe left the opening moments with a gentle grammar: conserve what turns. That rule, conservation of angular momentum, is quiet but strict. If something begins with a little spin and later shrinks, the spin quickens. If two pieces move apart, the total turning keeps its balance. This is why a skater draws in arms and twirls faster. It is also why a collapsing cloud of gas, losing size under gravity's pull, spins more briskly as it narrows. From those clouds, stars and their encircling disks are born. Planets condense in those disks and inherit their motion. The 24-hour turn of Earth is not an isolated habit. It is the leftover of that ancient swirl, a fossil of formation kept by an unbroken rule. The sun keeps its own rotation about once every 27 days, near the equator, twisting magnetic threads that sometimes knot into storms and flare into space. The Milky Way glides in a turn that takes roughly 230 million years to complete, its spiral arms lit by the births and deaths of stars. And when we stare deeper, past the lanes of dust in our own galaxy, we find systems so far away that their light began traveling more than 13 billion years ago. Some of those early galaxies already look organized, their stars moving in ways that suggest rotation had taken hold surprisingly soon. With instruments that can tease out the tiniest shift in color, one side just a touch redder, the other a touch bluer, we read the motion printed in the light and see the same preference. Matter does not merely fall. It tends to turn as it gathers. Not all signs arrive with fireworks. Some arrive as statistics. In 2011, astronomers examining a large sample over 15,000 spiral galaxies reported a slight imbalance in the directions their arms seemed to wind, as if the sky had a tiny preference that might trace back to the earliest conditions. Years later, in 2020, another study looked at more than 200,000 galaxies and suggested that one half of the sky hosts a mild excess of rotations in one sense, compared to the other. These are not verdicts, they are hints. The data sets are complicated, the methods are delicate, and the level of difference is subtle. But taken together with the microwave background's puzzles, they keep the door open to a possibility. The universe might carry, in its bones, a mild-handedness. The faintest suggestion that spin is not only local, but also global in flavor. Even the invisible scaffolding seems to keep time with a turn. Dark matter, the unseen mass that outweighs the glow of stars and keeps galaxies from flying apart, is followed in computer experiments like a flock through the ages. In those simulations, halos of dark matter show a habit of twisting and rotating over billions of years, cradling the bright disks we can see and guiding their growth like slow whirlpools guiding leaves. Without this dark architecture, spiral galaxies would likely shred under their own speed. With it, they remain coherent, their arms steady enough to host generations of suns. When we ask, who began the spin, physics leans toward an answer that is not a name, but a process: symmetry breaking. In the hottest beginning, the forces we now treat as distinct gravity, electromagnetism, and the nuclear forces were once braided together. As the universe cooled, that unity relaxed into separate strands. Perfect symmetry would have meant perfect sameness, which would have meant no place for structure to grow, no slope for motion to prefer, no spark for turning to catch. But the world did not choose perfect symmetry. It chose near symmetry, with tiny imperfections. Those small differences gave gravity something to work with, gave matter a way to prefer one arrangement over another, and set the stage for spin to be not only possible, but inevitable. You can see echoes of that choice in many places, in the direction galaxies coil, in the way certain particles favor left-handedness, in the slight biases that, multiplied by time and scale, become the patterns we see. The trace of rotation runs deeper still, into the quantum identity of matter. Electrons, protons, neutrons, each carries intrinsic spin. It is not spinning like a little ball on a needle. It is a property of the particle's nature, woven into its quantum state. We call it spin because the mathematics behaves like angular momentum, not because anything is literally whirling in the classical sense. Nevertheless, it behaves like a form of rotation. It couples to magnetic fields. It stacks and cancels according to rules. It arranges the architecture of atoms and the way electrons settle into shells. Even at the smallest scale, where our words struggle to keep hold, the universe keeps a ledger of turning. Step back from the chalkboard, and it becomes a story you can feel. The earliest fluctuations, stretched by inflation, left seeds. Gravity, faithful to conservation, amplified them. Clouds spun as they fell inward. Disks formed and rolled. Stars kindled in the centers, their planets circling like lanterns on quiet chains. Galaxies learned to be graceful, their arms shaped by density waves and held together by dark halos. On these arms, heavy elements were made and scattered, and on one small world in a spiral suburb, those elements learned to listen to the night and ask how this all began. Some caution belongs here, kindly and clear. When people speak of a rotating universe, the picture of a cosmic top can get in the way. If there is any global rotation at all, it would be very slight, so slight that no tree would lean, no ocean would heap up against an invisible wall. What the studies suggest, at most, is a preference written at enormous scales, a handedness so mild that only vast surveys and exquisite maps can tease it out. It would not contradict the apparent smoothness we see. It would whisper underneath it, like grain in wood that only appears from certain angles. The instruments keep learning to hear better. New telescopes gather light from galaxies born when the universe was only a few 100 million years old, roughly 300 million. In some cases, and already some of those systems seem to be organized and rotating. That early order does not prove a primordial spin by itself, but it fits comfortably with a universe that inherited motion from the outset rather than inventing it later. Meanwhile, the delicate chase for primordial B modes continues, not as a single dramatic hunt, but as a careful, steady refinement, inching toward a clean detection if nature has been generous enough to leave one. What then is the most faithful way to name the source of the turning we see everywhere? It may be simplest and truest to say that the universe did not learn to move. It began in motion. Quantum jitters provided the first unevenness. Inflation stretched those tiny differences and allowed curls to be possible. Symmetry breaking turned perfect balance into fertile imbalance. Conservation carried the early turns forward through every collapse and every flame. Dark matter gave structure a stable stage. Gravity wrote circles into the dark, and time started counting them. No single hand wound the clock. The clock assembled itself and kept ticking. Look up on a clear night, and what greets you isn't a frozen painting, but a slow choreography that began long before there were eyes to watch it. Every spiral of a galaxy is a page in that dance. Every ring around Saturn, every storm wheeling across Jupiter, every atom in a breath keeps faith with the same older law. The age we give the universe, about 13.8 billion years, marks how long this has been underway. We are not outside, pointing from a porch. We are inside it, made of its steps, carried by its momentum. There's a tender truth in that. Motion isn't an ornament laid over the world. It's the world's heartbeat. Even if the sharpest instruments never settle whether there is a grand twist to everything, the everyday verdict will not change. From the earliest fog to the first light and onward, the path is continuous. Motion is conserved. When matter gathers, rotation is favored. And the universe keeps the memory of beginnings in patterns so faint, you need patience to see them. Nature's handwriting, it seems, leans just a little. Follow that lean down from the wide sky until it touches ground, and you find the same story telling itself here. The atoms in your hands carry intrinsic spin. The iron in your blood was forged inside a turning star. The planet that holds you keeps an ancient day inherited from a long-vanished disk. The galaxy above completes a single turn across spans so long, entire histories rise and fade between the same 2 points of its arc. You are not separate from this current. You are shaped within it, and you keep its rhythm the way a leaf keeps the river's pace, by belonging to the water that moves it. Life arrives in rhythms, and one of the oldest is a turning so steady we forget to honor it. If the world did not spin, daylight would choose a single country and never leave. Darkness would hold the other forever, and the border between them would roar with storms. Instead, Earth keeps a patient wheel. Dawn yields to dusk. Warmth travels, shadows migrate, and the surface breathes in long, even sentences. A simple motion, repeated without drama, becomes shelter for weather and water and the slow work of living things. In the hush of that evenness, the vast dance above and the familiar cadence below meet and hold, and the room you sit in becomes part of a larger, reliable turn. Near the equator, the ground moves eastward at about 1,037 miles each hour. The turn is measured against the stars, a sidereal day of 23 hours, 56 minutes, and 4 seconds, and the steadiness of that period whispers under biology and climate alike. You do not need the numbers. It is enough to feel how the world keeps time with a spin, and how everything living has learned to listen. Plants angle their leaves, reefs pulse, birds find routes across hemispheres, and our own sleep keeps a truce with a sky that repeats itself. The first gift of rotation is the sharing of sunlight. No place owns the day, no place keeps the night. Energy is parceled out, and the gentle differences between morning and afternoon, between noon and evening, become gradients that move air and water. Wind is the atmosphere's way of balancing a world that never warms or cools all at once. Currents are the ocean's answer: carry heat away, return the cold, keep margins livable. Without a daily turn, one hemisphere would roast, the other freeze, and between them would lie a lifeless line of storms. Beneath the crust, another motion listens to the spin. The outer core is a sea of molten iron. As it moves, it builds a dynamo, and that dynamo weaves a magnetic field large enough to cradle the planet. Charged particles stream from the sun in a constant wind. Our magnetosphere bends that wind aside, funnels some toward the poles, and lets the rest slide around us. Where the particles are guided into the high atmosphere, they meet atoms and make light the auroras, soft curtains that glow as proof of protection. They are not just beautiful, they are evidence that the interior keeps moving, the rotating Earth, the continual flow of energy and charge. To see what a failing shield looks like, Mars holds up a caution. Its day length is familiar, about 24.6 hours, so the surface keeps a rhythm like ours. But the smaller planet cooled quickly. Its core lost the vigor to stir, the dynamo quieted, and the magnetic umbrella collapsed. With little to deflect it, the solar wind combed away the atmosphere, molecule by molecule, until what remained was too thin to hold oceans or warmth. The faint magnetism, locked in ancient rocks, is a fossil of the field that once guarded rivers and rain. Rotation shapes the air, even when skies are clear. As the planet turns, moving air is nudged sideways, a graceful bias called the Coriolis effect. It does not push with muscles, it persuades with geometry. North of the equator, large storms coil one way. South of it, they coil the other. Jet streams find lanes and hold them. High and low pressure systems spin like slow gears. Over the water, vast gyres carry warm tongues of sea into colder latitudes and return cool tongues toward the tropics. These spirals are not decorations, they are the bones of weather. Speed matters. A planet that spins far more quickly than Earth can build roaring jet streams and violent shear, its days flashing by so fast that the ground barely warms before night collects it again. A planet that spins too slowly lets one side overheat while the other loses heat faster than it can be replaced. Our 24-hour cadence is a middle path, long enough for energy to travel, short enough to avoid stagnation. In simulations of other worlds, slow spinners tend to split into extremes, and the fast ones grow harsh winds that never let the air settle. Somewhere between is a pace where circulation organizes into patterns that favor stability. Life tuned itself to this metronome long before calendars. Within cells are clocks, crafted of proteins and feedback, oscillators that run even in darkness. We call the larger pattern circadian rhythm, a roughly 24-hour cycle that governs when leaves unfurl and close, when nectar sweetens, when coral release their clouds, when birds begin and end their migrations, when our own hormones rise and fall like small tides. The alignment is not cosmetic, it is survival. Plants anticipate dawn, animals budget energy for foraging and rest. Bodies heal and remember on a schedule taught by a turning world. The moon enters this story like a companion with shared history. Long ago, a body the size of Mars Theia, as some call it, met the young Earth in a violent embrace. Debris gathered into a bright ring, and then into a single satellite. The impact did more than make a moon. It sped our rotation, leaving the day much shorter, something like 6 hours, on the newborn Earth. Over eons, tides raised by the moon's tug have acted like brakes, bleeding rotational energy into heat and slowly lengthening the day. The change is tiny in a human lifetime, about 1.7 milliseconds added to each century's day, but across geological ages, it has been enough to move us toward the gentler rhythm we now keep. That partnership does one more kindness. It steadies Earth's tilt, our axis leans, and that lean gives us seasons. Without a stabilizing companion, the tilt could wander drastically under the tugs of other planets, swinging climates from gentle to brutal and back again too quickly for complex life to adjust. With the moon's quieting hand, the wobble stays modest. Winters and summers arrive in their turns, and habitats have time to evolve with the rhythm rather than be erased by it. Look outward and different spins write different fates. Jupiter whirls once in about 9 hours 56 minutes. Its quick rotation carves the atmosphere into bands, sets up jet streams that circle the planet, and energizes storms that can outlast empires. The Great Red Spot, wider than Earth, has raged for centuries, fed by deep flows and sharp shears born of that furious day length. The result is not simple chaos. It is layered order, a woven tapestry of belts and ovals, a climate kept lively by speed. Mars stands between extremes. Its rotation is friendly to our sense of time, but its small heart could not keep a dynamo alive. Eons ago, rivers cut channels and lakes filled basins. With the field gone, the atmosphere thinned, water escaped, and the planet cooled into a quiet where dust devils write fleeting script on empty plains. In the rocks, magnetized patches remember the field that once was. The rule extends beyond our neighborhood. Worlds around other stars, giants like WASP 39b with sprawling atmospheres and compact, cooler planets in systems like TRAPPIST-1 show that rotation and circulation are partners. When a planet turns, even slowly, the air learns to move in patterns that share heat and balance chemistry. Without a turn, starlight can bake a day side to extremes while the night side hoards cold, and the atmosphere can slip into regimes where familiar molecules vanish or pile up. With a turn, heat is ferried, clouds find tracks, and models predict steadier temperatures and traceable gases around the globe, making a more even world. Time itself, as we live it, is grounded in motion. A second is defined by an atom's vibration, but the meaning of a day and a year, the calendar that arranges work and celebration and rest, rests on Earth's turning and Earth's path around the Sunday. When we say morning or season, we are naming positions in a cycle. We are standing inside a clock built of motion. That clock drifts, and we correct it with leap seconds and calendars that swallow extra days. But at its heart is a spin and an orbit singing together. There is a quiet elegance in how the ancient violence of formation has become a cradle. The same momentum that flung debris into a ring gave us a moon that steadies our tilt and raises tides that stir coastal life. The same conservation that tightened the spin of a collapsing cloud endowed Earth with a day that lets warmth travel and coolness return. The same geometry that bends moving air gives storms their structure, which, despite their danger, carry water inland and feed forests far from the sea. The chain reaches from iron flowing in the core to curtains of green above a meadow, from global circulation to snowpack to rivers that ease a valley's thirst. Each link is simple. Together, they feel like grace. Treat the key figures as small talismans rather than burdens. About 1,037 miles per hour at the equator, a sidereal day of 23 hours, 56 minutes, and 4 seconds. A lunar break that adds roughly 1.7 milliseconds per century. A Jovian day of 9 hours, 56 minutes. A Venusian rotation of 243 Earth days, backward. A Martian day of 24.6 hours, and a field lost to cooling. Each number is a thread, and together they weave a fabric thick enough to hold oceans and thin enough to let ideas pass through. What begins as physics arrives as feeling. The pink of dawn, the wind that turns with evening, the way a storm spends itself and leaves a clean, ringing dark. Life did not merely endure this rotation, it grew up with it, learned its cues, and folded them into its own music. Asking whether spinning made life possible is like asking whether breath needs air. The answer is quiet and steady. This motion isn't an ornament, it's the center written in cloud streets, in the clockwork of tides, in the deep memory tucked inside seeds. Hold that thought. The same cosmic swirl that once gathered dust into a planet now turns that planet toward morning, then toward night, lifting water into clouds and laying it down as rain, holding a magnetic veil between us and harsher suns, opening seeds, waking sleepers, giving us a language for time. Even if the rate of turning drifts by imperceptible degrees across ages, the gift remains. A world where energy moves, climates breathe, and living things find a tempo that fits their hearts. And at the rim of that circle waits one more truth. Rotation is not only a way matter travels, it is a way moments add up. Go fast enough, turn tight enough, and time itself begins to show its humility, slowing by a whisper for those caught in the speed. That is where the glide becomes a bend. Push rotation far enough and it ceases to be only motion through space. It becomes a shaping of space and time themselves. Long before we had words for it, the universe behaved as if gravity and motion were two faces of the same quiet law. When Einstein finally wrote that law down in 1915, the mathematics said something delicate and astonishing. Mass and energy curve spacetime, and rotation can twist it not as metaphor, but as a real, measurable dragging of the very stage on which events unfold. Imagine the fabric of spacetime as a very calm lake before dawn. Set a heavy sphere in the water, and the surface sags around it. That is gravity's familiar pull. Now spin the sphere. The water near it begins to swirl. In relativity, a rotating mass does something similar. It stirs the geometry, creating barely perceptible eddies in the flow of time and the direction we call around. Physicists name this frame dragging. And though the effect near Earth is small, it is not imaginary. Francis Everett, who led the Gravity Probe B mission, once offered a homely picture: a spinning ball twisting the honey it sits in. It's a kitchen image for a cosmic truth. Gravity Probe B carried gyroscopes so refined that their axes would keep their aim for a year with almost no internal complaint. Those gyroscopes, falling around Earth in a quiet orbit, registered two tilts, one from Earth's static curvature, the other from Earth's spin tugging space-time into a subtle whirl. The measured twist was about 0.000011 degrees per year, exactly the kind of whisper Einstein's equations predict. The number is tiny, but the meaning is vast. Even a planet with a 24-hour turn can make time and space shrug a fraction, nudging the path of a perfect gyroscope simply by rotating. Turn the dial from gentle to fierce, and the story grows urgent. When a massive star ends its bright life, it can collapse into a neutron star, a sphere roughly the size of a city, about 20 kilometers across, yet heavier than our Sunday. In the fall, angular momentum is conserved. What once rotated slowly as a star swells into a rapid spin as a cinder. Some neutron stars rotate hundreds of times each second, pulsars whose magnetic poles sweep the sky with beams, a lighthouse rhythm you can set a clock by across the galaxy. Their gravity is so intense that time close to the surface runs noticeably slower than it does far away. Instruments on the International Space Station, like NICER, have traced the light skimming these extreme objects and shown that space-time near them is warped enough to change clocks and bend paths in ways our equations fully expect. Increase the spin, deepen the gravity, and a second near the star drags out compared to a second in your room. It isn't magic, it's geometry. Go one step deeper, and the world becomes a kind of wilderness. A rotating black hole, the solution found by Roy Kerr in 1963, is not just a pit that swallows every path inward. It is a pit that swirls the very grid of space-time around its axis. Outside the event horizon lies the ergosphere, a region where standing still relative to the distant stars is impossible. There, every particle and every beam of light must, in some sense, go with the flow. The lake of space-time is not only depressed, it is also spinning, and the current is irresistible. Close enough to the horizon, the current approaches light speed, and all timetables bend to its will. Pictures help, and the sky has been kind enough to give us some. The Event Horizon Telescope stitched together radio observatories across Earth to form a planet-sized lens. The first image it produced in 2019 revealed the dark silhouette of the black hole in M87, encircled by a luminous ring where infalling matter glows. In 2022, it offered the shadow of Sagittarius A*, the black hole at the center of our own galaxy. The ring's uneven light, its shape and thickness, carry the marks of curved paths and delayed photons, evidence that rotation and gravity together are sculpting the routes light can take and the order in which its signals arrive. In X-rays, observatories like Chandra, XMM Newton, and NuStar have watched echoes flicker around black holes as light loops briefly in warped space before escaping a tiny reverberation chamber where time is stretched like a soft thread. These same principles brush our lives every day without drama. Satellites high above the ground run on clocks that do not tick at exactly the same rate as clocks on Earth's surface. Two effects compete. Motion slows the satellite's time a little, while being higher in the gravitational field speeds it up a little more. The net result is a drift of about 38 microseconds per day. Left uncorrected, that tiny mismatch would blur GPS positions by miles. The corrections are routine, folded into the systems that guide planes, ships, and walks through a city. In a quiet way, every time you find your location, you are using Einstein's bookkeeping of time and motion. Near a Kerr black hole, the bookkeeping grows baroque. The mathematics allows something called closed time-like curves paths through the warped geometry where, in principle, a traveler could loop back to an earlier event in their own history. Whether nature permits those loops to exist physically, with all their paradoxes, is an open question colored by quantum fields and the stubbornness of causality. But it is telling that rotation alone, when married to strong gravity, can bend the sequence of events in ways that make language wobble. What one observer calls later may, in these conditions, cross another's earlier, not as a trick, but as a lawful outcome of how space-time is layered and twisted by spin. The same redshifts that measure the universe's expansion also help weigh the slow clocks near violent hearts. The deeper the potential well and the faster the spin, the more the light we receive is stretched. Spectra from quasar disks, enormous hot rings of gas feeding supermassive black holes, show that the inner regions are so close to the brink that their time is measurably dilated. With infrared sensitivity, newer observatories can disentangle cooler dust from the blazing core, letting models pin down how fast the disk is rotating and how sharply time is being bent there. Some of the photons now reaching us began their journey more than 13 billion years ago and have spent part of that journey in places where minutes and hours are not the same everywhere. Frame dragging does not require extremes to be real. It simply becomes visible sooner when the spin is violent. Around Earth, it is a patient drift. Around neutron stars, it becomes a shove. Around black holes, it turns into a river that cannot be weighted against. If you could hover safely near the edge of an ergosphere, an impossible perch, for now you would watch distant clocks race while your own hesitated. A conversation that takes moments for you might cost an hour out in calmer space-time. The difference would not be a mistake of your instruments. It would be the world obeying its rules. There is a temptation to think of light as immune, a champion that always does as it pleases. It always moves at the same speed locally, but the routes available to it are not of its own choosing. Rotation in a strong field can force light to take detours, to circle, to pause in shallow orbits before it can climb away. When it finally reaches us, the pattern carries delays and brightening that tell of the labyrinth it threaded. In those delays, those echoes, you can time the geometry itself. On the very largest canvas, people sometimes wonder whether the universe carries a twist that could sway the grand flow of time from place to place. The best maps of the early afterglow, the cosmic microwave background, do not show a strong overall rotation, and yet there is room for the faintest preference to leave fingerprints in polarization, like a grain in wood, seen only in raking light. Even if those whispers someday prove real, they would be nothing like a cosmic merry-go-round. They would be lean, statistical tilts across billions of light years, more suggestion than command. Down here, the pattern is simpler and humbler. Time slows when motion is fast or gravity is strong. Every altitude change, every speed change, brings with it a precise adjustment, and we have measured those adjustments in aircraft, on mountaintops, with atomic clocks that drift so little that days must be counted in decimals. The universe insists on balance. Increase energy in motion, and time yields a little. Step into a deeper gravitational well, and time yields a little more. None of it is theatrical. All of it is consistent. If rotation can bend time, It is because rotation is part of the energy that shapes space-time in the first place. A spinning mass does not just occupy a region, it instructs the geometry around it to swirl. That swirl sets the stage for how events can unfold, how signals can travel, how fast a clock may run. From Earth's mild tug on gyroscope axes to a black hole's grip on the order of cause and effect, the same equations thread through, linking motion, gravity, and duration into one quiet fabric. It can be calming to think that your own minutes are braided with turns you cannot feel. The Earth's spin, the sun's pull, the galaxy's slow wheel, all of it contributes to the definition of now that you carry. You are not separate from the mechanics that write time. You are written by them and alongside them. The second you read on a watch is a human convention tied to a physical world that never stops negotiating. There is also a reciprocal question that sits like a pebble at the edge of the path. If spin can slow clocks and tilt schedules, does time in turn govern spin? Does the fabric, once twisted, encourage further turning, or steal from it, or set limits we have only begun to sense? In the best stories nature tells, cause and effect form a loop, each side shaping the other, not in contradiction, but in companionship. For rotation and time, the companionship is intimate. The more something spins, the more it bends time. The more time is bent, the more the possibilities of spinning are circumscribed and redirected by the shape that bending makes. What remains after the math and the measuring is a strangely tender conclusion. Rotation doesn't just carry matter from place to place, it sets the tempo of the moments nearby. The effect is gentle enough to steer a satellite, strong enough to choreograph storms on Jupiter, and wild enough to make a galactic core where a minute can wear the weight of an hour. From a gyroscope's fragile drift to the fierce whirl of plasma near a horizon no light can cross, the universe keeps the same promise. Motion and time are one conversation, and spin gives that conversation a curl. Yes, rotation can bend time. It can slow a clock, bend a path, even tangle before and after, where gravity is deepest and the turning most intense. The pattern isn't arbitrary, it's a law everything obeys. And that law doesn't live only in distant fields and heavy hearts of stars. It folds down into our days. Every second you live is braided with motion. The watch on your wrist keeps a private rhythm pinned to deeper, turns the whisper of electrons in atoms, the steady roll of the planet underfoot, the wide, slow wheel of the galaxy overhead. Even a heartbeat keeps quiet company with the spin that brings light and dark in their turns. When the turning is gentle, it's easy to forget that time and spin share the same page. But they do, faithfully. At every scale we know the same conversation, carried from the edge of a black hole to the room you are sitting in now. Begin with the kind you can name without instruments. Earth turns once each sidereal day, 23 hours, 56 minutes, and 4 seconds, carrying the equator eastward at about 1,037 miles an hour. That steady glide doesn't rattle glasses or make the trees lean, but it has a tiny say in how your seconds pass. Clocks at the equator tick a breath, slower than clocks near the poles, not from heat or altitude alone, but because motion and gravity alter time's pace. Relativity is quiet about it. It simply keeps the books. Move faster, and your time leans. Stand deeper in a gravitational well, and it leans again. Add the two leanings together, and you have the particular tempo that belongs to a place. The effect is small, but not imaginary. A clock resting at sea level just north of the equator is both moving faster and sitting a little deeper in Earth's gravitational potential than a clock high in the Andes or quiet on Antarctic ice. The first clock will lag by nanoseconds each day. On paper, those numbers look like dust. In practice, they steer machines above the sky. The satellites that tell us where we are, 24 of them in the GPS constellation alone, circle about 12,500 miles above the surface at roughly 8,700 miles per hour. Up there, gravity's grip is weaker while speed is high. Their onboard atomic clocks, careful, as monks would run ahead by about 38 microseconds per day if left uncorrected. A handful of microseconds doesn't sound like much, but it turns into miles of error on the ground. So engineers fold Einstein into the circuitry, trimming and adding ticks so that every map in your pocket remains faithful. Each position fix is a small testament. Space, time, motion, and spin are collaborating even when the sky looks empty. If spin can lean on time, it is fair to ask what leans on spin. The best answer begins in a lab, with a metal vacuum chamber and a patient beam of microwave light. Inside modern atomic clocks, atoms, often cesium-133, offer a transition so reliable that we define the second by its beat. 9,192,631,770 cycles of radiation between two hyperfine levels in the ground state. That mouthful is not a flourish. It is how civilization agrees on what a second is. The word spin hides in that definition because the splitting between those hyperfine levels depends on how the intrinsic spins of the electron and the nucleus couple. In quantum mechanics, spin isn't a little ball whirling. It's an intrinsic angular momentum, a built-in property of particles that behaves like rotation in the math and in the way matter meets magnetism. That property sets energies. Those energies set frequencies. Those frequencies set time. The chain is intimate. The tick on your screen is ultimately a translation of a quantum spin conversation. The same story steps outward without losing its grammar. Days are Earth's rotation carved into habit. Years are orbits written as seasons. These motions drift a little, and we keep up with them in ways that blend astronomy and engineering. The moon tugs tides through ocean and rock. That pull saps Earth's rotational energy and lengthens the day by about 1.7 milliseconds each century. It doesn't change anyone's bedtime tonight, but it matters to the long arithmetic, because atomic seconds remain crisp while planetary spin slowly eases. Every so often, we insert a leap second into coordinated time to let the human schedule stay in step with Earth's. It is a tender arrangement, clocks made of quantum rules waiting for a planet made of iron, water, and sky to catch up. If you compare the role of spin across scales, a pattern emerges. In atoms, spin sets allowed states, decides who may share a quantum room, and shapes chemistry through the Pauli exclusion principle, no two electrons allowed in the same state. In weather, spin shows up as the Coriolis turn that helps storms organize and jet streams find their lanes. In satellites, spin and motion need to be accounted for, or else maps wander. On the ground, a gyroscope keeps its direction in a rotating world and reveals that the world turns at all. In each case, timekeeping is not free-floating. It rests on motion you can trace with a finger, back to a conserved quantity older than planets. Ask who started the turning, and the scene returns to a wide, cool cloud 4.5 billion years ago. Gas and dust, sparse as a whisper, drifted in a region that would become our neighborhood. Gravity does what it always does. It gathered. As the cloud fell inward, Any tiny initial spin was amplified by conservation of angular momentum. Shrink a radius, and the rate must rise to preserve the product. It is the same law that pulls a figure skater into a blur when arms draw close. A disk formed, the sun kindled, and rings of material coalesced into planets. No hand is needed to keep those planets spinning afterward. In space, where friction is scarce, inertia is king. A body will keep its rotation until something torques, it tides, impacts, magnetic couplings, the soft breaking of a planetary wind. The universe, once set into motion, needs no caretaker to maintain the turn. Spin never sits idle. The sun rotates about once every 27 days near its equator, but not all of it keeps the same pace. The poles turn more slowly. This differential rotation stretches and twists magnetic fields, stores energy in loops that can snap, and throws off flares and coronal mass ejections. When those storms sweep across the orbit of Earth, they push on our magnetosphere, rattle satellites, paint auroras, and sometimes test the patience of power grids. Here, too, time slips into the narrative. A flare erupts, particles race, fields rearrange. Instruments on Earth and in space time-stamp the journey, and in those time-stamps lie the fingerprints of relativity signals delayed, clocks shifted by altitude and speed, geodes counted in precise pulses so that engineers can disentangle what happened and when. Broaden the frame again, and star by star, a larger clock appears. The Gaia mission has mapped motions for well over 1 billion stars, showing how the Milky Way completes one slow rotation in about 230 million years. That number is not a metaphor, it is a lap time. Each orbit is an entry in a ledger of galactic time, written by gravity and angular momentum, and legible in the dance of open clusters and streams of stars pulled from dwarf galaxies that wandered too close. The galaxy spin is not a device to consult. It is a background tempo, the kind that shapes the long weather of habitability over eons, by guiding where clouds of gas collect, where spiral arms compress matter, where new suns can be born. The same law of conservation joins these scales without strain. Angular momentum doesn't vanish, it migrates. A slowing Earth hands a sliver of its spin to the moon's orbit, nudging the moon a touch farther away each year. Two skaters push and separate, each carrying off a share of the initial turn. In the heart of an atom, a photon departing with a twist changes the spin accounting of the electron it leaves behind. Colliding galaxies tangle their spins and bars and halos until a new equilibrium appears, with angular momentum flung outward into tidal tails. Over and over, the total stays the same while the pieces trade. Sometimes the trading has to be measured with care before it can be believed. Place two ultra-precise clocks at different latitudes, and their disagreement will match what relativity predicts. Send one clock up a mountain and leave the other by the sea, and the difference will agree again. Fly atomic clocks around the world on aircraft, and when they return, they will not match their twins that stayed home until the equations are applied. None of these tests require faith. They require patience and a willingness to trust that even when differences are measured in nanoseconds and microseconds, reality does not shrug. It whispers, and the whisper is consistent. So who controls all this spinning? The quiet answer is that control is the wrong word. The universe keeps balance, not orders. Angular momentum is conserved because the deep symmetries of space, the way the laws do not change when you rotate your experiment, demand that conservation. No supervisor enforces it. It falls out of the structure of the rules. In that sense, the who dissolves into a how. The how is symmetry. The how is inertia. The how is that motion left to itself continues, and when motion is exchanged, it is exchanged in ways that do not cheat the totals. The second you count by cesium's light echoes that. The day you live by Earth's turning echoes it. The long galactic year carries it in every orbit. This does not make spin passive. It sculpts. It decides which molecular bonds are possible, which magnetic materials can be made, how the interior of a planet circulates heat, where storms find their structure, how a star sheds its outer layers at the end of its life, and how newborn systems inherit the turns of their parents. It shapes the measurement tools that shape our days. Every GPS fix, every synchronized network, every financial trade timed to a fraction of a microsecond relies on clocks whose frequencies depend on quantum spin and whose rates are corrected for motion and gravity. The modern world is quietly braided to the cosmos by these threads. Look far enough back, and the link between spin and time appears almost immediate. Light from galaxies more than 13 billion years away shows hints of organized motion disks already forming when the universe was young. Rotation, it seems, did not wait for leisure. It was there as soon as structure could hold it. That is not a separate rule. It is the same conservation playing out at a new scale, the same symmetry expressing itself as order rather than chaos. If all this feels large, bring it close again. The atoms in your blood carry intrinsic spin. The iron in hemoglobin owes its magnetic personality to electrons arranged by spin rules. The quartz in a watch, the cesium in a clock, the superconducting loops that trap magnetic fields for sensors, all of them are made obedient by the same quiet, angular momentum bookkeeping. Meanwhile, the floor beneath you rides a rotation, so even you can fall asleep on it without ever feeling a push. The moon above you steals a whisper of that rotation each night to climb a little higher. The sun that warms you spends its rotation on magnetic knots that sometimes send ribbons of charged particles to ignite a polar sky. The galaxy that holds you circles in a period so long that mountains rise and fall before one turn completes. None of these need permission. They follow from balance. Sometimes people hope for a master clock, a final authority that tells all other clocks how to behave. The reality is more elegant. The second is defined by a transition in an atom. The day is defined by Earth's spin. The year is defined by Earth's orbit. The epoch is touched by the galactic lap. Each is local, each is real, and each is reconciled to the others by the same equations that relate motion, gravity, and time. Where they differ, we use leap seconds, ephemerides, and relativity corrections to stitch them into a single fabric for our purposes. The stitching is our work. The cloth is the universe's. If there is a moral hidden in the arithmetic, it may be this. Time is not an independent drum beating behind things. It is a tempo that emerges from how things move and how the fabric that holds them curves. Spin is one of the cleanest ways the cosmos writes that tempo. Remove spin from the equations, and the geometry grows simpler, flatter, less storied. Include spin, and the stage gains a curl, a preference that can slow a clock, bend a path, and organize matter into disks, rings, and storms. So when the question returns, who controls the spin, the answer arrives without sound. No one must. The balance is self-kept. A cloud collapses and spins because nothing forbids it, and because conservation insists. A planet keeps its day because there is nothing to stop it except the soft hand of tides. A clock keeps its second because a quantum transition repeats with devotion, and engineers compare that devotion with the sky's slower drift. What is given up in one place is taken up in another. What slows here speeds a companion there. The sum remains. Hold that gently. Your minutes and hours are not apart from the turning. They are carved by it. The electrons in your cells, the cesium in a clock, the earth under your feet, the sun that sets, the spiral that roofs the night each turns, each keeps the others honest, and together they make something we can live inside and call time. If balance is the rule, then the moments that seem most still are simply the ones where sharing is perfect, where the turns cancel into a hush. And if a hush can be born from balance, it leaves a small wonder to consider in the dark. When balance falters, when a symmetry loosens just enough to let difference in what new patterns might step forward from the quiet and take their place beside spin as keepers of the world's rhythm, perfect balance would be a beautiful prison. If every direction were identical and every possibility matched its mirror, there would be nothing to choose, nothing to prefer, nothing to begin. No star would condense, no atom would settle, no second would pass. The world we live in suggests something else happened, something small and decisive. A slight tilt away from perfection let motion appear, let structure take root, and gave time a sense of forwardness. What we call the universe may be the long unfolding of that first gentle misalignment. Physicists use symmetry to mean a kind of impartiality in the laws themselves. Turn the page, slide the frame, switch observers, and the rules do not flinch. When symmetry holds exactly, there is no built-in reason for change. Every option is equivalent, but even a faint departure breaks the stalemate. A ripple in density, a bias in a field, a preference in a particle's behavior. These let gravity find something to gather, let forces distinguish roles, let stories develop. Imperfection becomes a doorway. Drift back, as softly as thought will allow, to the first sliver of a second after the beginning. The young universe was a hot, dense plasma, everything crowded and bright. In some visions of that earliest instant, the familiar forces, gravity, electromagnetism, the strong and weak nuclear forces were intertwined. As expansion and cooling proceeded, that unity relaxed. One by one, symmetries that had held at higher energies became unstable and chose particular configurations as temperatures fell. This is spontaneous symmetry breaking. No hand pushes, no external command arrives. The system itself finds a lower energy arrangement and, by doing so, creates differences that matter. We keep a photograph from that childhood, a portrait in microwaves. Long after the fireball thinned enough for light to travel freely, its afterglow remained and was stretched by expansion into the cosmic microwave background. Satellites listened to that faint radiation and heard a pattern. Astonishing uniformity, yes, but not perfect. The temperature varies by roughly 1 part in 100,000. Those minute variations in energy density are the earliest fingerprints of broken symmetry written across the sky. Left alone, a perfectly uniform fog would sit quietly forever. With these tiny swells and hollows, gravity had a slope to follow. Matter began to drift toward overdensities, and from that slow migration came the scaffolding of galaxies, the lighting of stars, and the long chain of chemistry that ends in oceans and breath. Even the existence of matter as something more than light is owed to imbalance. In the first moments, reactions made matter and antimatter in nearly equal amounts. Nearly is the hinge of the tale. If creation had been exactly symmetrical, every particle would meet its twin and vanish into radiation, leaving a universe of pure light. Instead, there was a slight excess, about one extra particle of matter in every billion pairs. When annihilation finished, that tiny remainder was left to build everything visible. The trace of preference shows up in the lab, too. In 1964, an experiment with neutral kaons revealed that the laws of physics treat matter and antimatter just a little differently. We call this CP violation. It is delicate, it is real, and it was the first concrete sign that nature's rules lean ever so slightly. Without such a lean, there would be no atoms to arrange into hands and questions. Another piece of the story arrives with the Higgs field, which did not flicker on like a switch so much as it settled like dew. At energies higher than those of the modern universe, the electroweak force held together as a single entity. When the cosmos cooled below a critical scale, on the order of 10 to the power of -12 seconds after the beginning, the Higgs field took on a non-zero value everywhere. That decision, if a field can be said to decide, broke the symmetry between light-like particles and those that acquire mass. The result is the world we recognize. Some particles carry the inertia that lets them build atoms. Others remain massless messengers. You can think of it as the moment the stage took on texture, so actors could be more than streaks of light. Not all breaking is violent. Some is like a balanced pencil that will not stand forever, even in a quiet room. At the very beginning, the direction of time might have been as symmetric as any other, equally comfortable flowing either way. But the universe began in a state of unusually low entropy, a kind of order that is statistically rare. From that starting point, entropy tends to increase, and this tendency is what we feel as the arrow of time. It is not that laws forbid running the movie backward. It is that the initial condition tips the probabilities, and the tipping is remembered by everything that follows. The direction we call future is the one in which disorder spreads. Across scales, the same theme repeats as if the cosmos were humming in harmony with itself. On the largest maps, galaxies do not fill space evenly. They gather along filaments and sheets, leaving broad voids between them. Those filaments are drawn by dark matter, the unseen mass that answers gravity's call, and they trace the amplified echoes of the earliest quantum fluctuations. The deep fields of modern telescopes show young galaxies lining these invisible threads, already taking their places in a grand architecture that began as randomness and matured into pattern. Without asymmetry, gravity would have no preference, and the web would not appear. At the smallest scales, particles keep the refrain. Neutrinos come only left-handed. Their spin and motion align in a single sense, a built-in chirality. In chemistry, life favors specific-handedness too. Amino acids on Earth are almost entirely left-handed. Sugars prefer right-handed forms. Why should biology choose? Perhaps because long before there were cells, light in the early universe carried polarization that could subtly bias the destruction and survival of mirror molecules. Perhaps because local environments on early grains of ice carried magnetic or radiation preferences. Whatever the path, handedness repeats, from neutrinos to molecules to the way some galaxy populations show mild imbalances in their directions of rotation. Each echo is quiet on its own. Together, they sound like a chorus. The polarization of the microwave background carries its own soft clues. If the universe experienced a brief, astonishing growth spurt known as inflation, then it would have launched ripples in space-time primordial gravitational waves. Those waves leave a distinct curl pattern, called B-mode polarization, in the afterglow's light. Measuring such patterns cleanly is hard. Dust and instruments have their say. But if the signature is truly there and can be separated from foregrounds, it would be evidence that the earliest act of the cosmos involved both stretching and a kind of curling symmetry not destroyed, but loosened just enough to make movement possible. There is another symmetry so deep we often forget to name it: translational and rotational symmetry in the laws themselves. When the equations do not change, if you shift your experiment or rotate your apparatus, conservation laws appear as if by magic. Energy conserved, momentum conserved, angular momentum conserved. This is more than a bookkeeping trick. It is the logic behind why a spin, once acquired, persists until torqued, and why a cloud collapsing under gravity must rotate faster as its radius shrinks. The persistence of rotation, the inheritance that lets disks form and planets keep days, is itself a gift of symmetry, paradoxically born from a law that says all directions are equivalent. Only when the system cools and chooses a particular alignment does that equivalence break and structure blossom. In a perfectly uniform universe, gravity could not gather matter into a star because there would be no more and less to distinguish one region from another. With the tiniest unevenness, gravity turns into a sculptor. A little extra matter attracts more, and the attraction feeds on itself. Clouds thicken, centers condense, fragments spin, lights turn on. By the time heavy elements are forged and flung outward by dying suns, the history of broken symmetry is written into the periodic table. Iron in blood, calcium in bone, phosphorus in thought, all are downstream of that first refusal to be perfectly smooth. Everywhere we look, preference shows through. Some surveys of spiral galaxies have reported slight imbalances in clockwise versus counterclockwise spins over great stretches of sky, small biases that may trace environment or perhaps memory from initial conditions. The evidence is statistical and cautious, as it must be, but the suggestion matches the mood of the rest of the cosmos. Perfection did not rule, nuance did. The beauty of all this is that broken does not mean ruined, it means chosen. Symmetry breaking is not a fall from order, it is the source of forms. Imagine a field, stretched taut across space. At high energy, it sits right at the top of a hill, symmetric, poised, indifferent. As the universe cools, the field slides into one of many equivalent valleys. Choosing a valley breaks the pristine symmetry and, at the same time, makes new particles heavy, turns forces into distinct actors, and sets interaction strengths. The world gains texture by giving up uniformity. The cosmic microwave background tells the same story in a different language. Its smoothness reassures us that inflation happened. Its tiny mottling reassures us that inflation did not erase the seeds of later complexity. Those seeds grew into the cosmic web, guided by dark matter's gravity. Along the filaments, gas cooled and settled into rotating disks. Inside those disks, stars crowded, and around some stars, dust learned to become rocky worlds and seas. At each turn in this chain, a symmetry was present, then softened, then picked a direction just enough to let the next structure exist. The arithmetic from the beginning still echoes in your own materials. Matter outnumbered antimatter by about 1 in a billion, and that is why there is anything to arrange into life. The bias is unimaginably small compared to the total, and unimaginably decisive compared to zero. Each atom in a hand or a heartbeat exists because, long ago, one extra particle refused to find a partner and vanish. Imperfection left a remainder, and the remainder learned to glow and to think. It helps to hold two ideas at once. First, the deep laws are symmetrical in ways that give us conservation and predictability. Second, the world we inhabit is not a perfect expression of those symmetries. It is the result of their gentle breaking. From that combination comes a universe that is lawful without being sterile, capable of stability and capable of surprise. The slight differences in energy, in charge, in alignment, in spin, are where motion finds a foothold. They are where time finds a slope. When telescopes collect ancient light, they are not only taking pictures, they are reading a fossil record of choices. The faint modeling in microwave maps, the alignment of galaxies along filaments, the lopsidedness in matter over antimatter, the handedness in neutrinos and amino acids, all are entries in a ledger that begins in the first instant. You can trace a line from a fluctuation so small it could be described only by probability, to a filament so long it connects clusters of galaxies, to a planet stable enough for water to pool, to a creature able to notice all of this and speak softly about it in the dark. Take the thought personally, if you wish. You are living proof of asymmetry. The atoms in your body are the survivors of an ancient vote that was nearly tied and yet not quite. The blood that moves oxygen owes its chemistry to electrons, arranged by spin rules in a world where electroweak symmetry is broken. The light that lets you read is generated by stars sustained by structures that gravity could not have made without initial unevenness. Time, as you feel it morning turning to evening, memory stretching behind you, is the large-scale consequence of starting low in entropy and walking, always, toward higher. Perfection is a fine idea for mathematics, but the universe prefers something more capable. Symmetry offers elegance, asymmetry offers life. A small crack in balance opened the way for everything that would ever spin, shine, or breathe. And once motion began, it carried another question inside it, a quiet tension that lingers in the spaces between galaxies. If broken symmetry allowed structures to grow, and if those structures rotate faster than visible matter alone can hold, what is the hidden strength that keeps them from flying apart? What unseen thread binds the whirling together in the dark? Spin should fling things apart. Out at the faint edges of a spiral, stars circle so quickly that if only the light we see mattered, they would peel away like sparks from a grinding wheel and fade into the dark. But they do not. The arms hold. The disk keeps its shape. Whole swarms of suns move as if cradled by something we cannot see, an invisible weight that steadies the dance. We call that unseen presence dark matter. It is not dark because it is shadowed. It is dark because it does not make, reflect, or block light. It passes through the everyday forces that glue atoms together as if they were fog, and yet it pulls. Gravity is the single conversation it insists on having, and the universe listens. The first clear whisper of this came from a man with a blunt way of speaking and a talent for noticing what figures could not hide. In the 1,930 seconds, Fritz Zwicky measured how fast the galaxies in the Coma cluster were moving. There were hundreds upon hundreds of them, more than 1,000 islands of stars drifting roughly 320 million light-years away. By counting the visible mass stars, gas, dust, he concluded that the cluster should have flown apart. The galaxies were racing too quickly to be held by the gravity of what could be seen. Zwicky proposed that some missing mass must be there, outweighing the luminous stuff by a startling factor. He named it in German Dunkel Materie, and the phrase stuck in English as dark matter. For a long time, his claim sat like a note in the margin of the field, provocative, inconvenient, and waiting. Decades later, a quiet revolution arrived, not in the violent collisions of clusters, but in the steady turns of ordinary spiral galaxies. In the 1,970 seconds, Vera Rubin and her collaborators aimed spectrographs at Andromeda and many other spirals, tracing the speeds of stars at different distances from the center. If gravity came only from the bright disk and bulge, the speeds should fall as you move outward, just as the outer planets circle the sun more slowly than the inner ones. Rubin's plots refused to bow. The curves were flat. Stars far from the center were moving just as fast as those much closer in. That should not have been possible with visible mass alone. Something extended and massive had to be there, providing extra gravity all the way to the outskirts. The conclusion was at once simple and astonishing. There is much more mass than meets the eye. From these two threads, clusters that hold together when they shouldn't, and galactic edges that move too fast to be bare, we wove an image that now feels like the background of every night. Galaxies live inside halos of dark matter. These halos are vast, ballooning far beyond the rim of the visible disk, sometimes out to 200,000 light-years or more. They are not shells or shells within shells. They are smooth, extended wells of gravity, lightless and patient. The bright parts of galaxies, the disks and bars and bulges where stars are born, are like lanterns hung within an invisible framework. There are ways to watch the framework without ever touching it. Gravity bends the paths of light, not because light is heavy, but because space-time itself curves around mass. When a cluster of galaxies sits between us and more distant galaxies, the intervening mass acts like a lens. The background is stretched and magnified, smearing into arcs and multiple images. By mapping these distortions, astronomers can weigh the lens, even the part that refuses to glow. One of the most eloquent examples is the Bullet Cluster, a collision between two clusters that barreled through each other. X-ray images show the hot gas, the bulk of ordinary matter, slowed and pooled where ram pressure made it lag. But the gravitational lensing peaks lie ahead, with the galaxies that punched through. Most of the mass moved on. Most of the ordinary matter did not. Visible and invisible separated, and the invisible carried the weight. It is a quiet, stubborn demonstration that the gravity binding these systems cannot be explained by the light alone. On smaller scales, the case stands on many legs. Spiral galaxies with flat rotation curves, dwarf galaxies whose stars move as if immersed in halos far larger than the visible core, ellipticals whose motions betray an unseen hand, satellite galaxies around the Milky Way, their orbits and dispersions whispering of a massive halo all around us. Even the way large clusters bend the cosmic microwave background, the subtle imprint called the Sunyaev-Zeldovich effect, fits best when the heavy lifting is done by dark matter. If the unseen mass is real, what is it made of? The list of suspects reads like poetry written in a lab notebook. WIMPs, weakly interacting massive particles, heavy and shy, predicted in some extensions of the standard model. Axions, feather-light and plentiful, born from a mathematical need to tidy up the strong force. Sterile neutrinos that barely whisper to normal matter. Makos, ordinary dark things like black holes and brown dwarfs, once suspects, now largely cleared as the sole culprits. The experiments chasing these candidates live deep underground, in caverns and old mines, their detectors bathed in silence and shielded from cosmic rays. Xenon-filled time projection chambers watch for a rare tap on a nucleus. Liquid argon tanks listen for the faintest flash of a recoil. So far, no definitive handshake, only tighter bounds and better patience. In the sky, telescopes like Fermi look for gamma-ray glimmers, where dark matter might annihilate itself in crowded centers. Nothing certain, only hints and constraints. The search continues because the scaffolding is everywhere, and one day a particle may leave a trace. Meanwhile, our models of how galaxies form and grow have learned to trust the unseen. Computer universes Illustris, Eagle, and others begin with a simple recipe: tiny ripples in an otherwise smooth distribution of matter and energy, an expanding space, and the rules of gravity, gas dynamics, and radiation run the clock forward, and the dark matter collapses first into a web, filaments, nodes, and broad empty rooms called voids. Along the filaments, halos gather and merge. In their wells, gas cools and settles into disks. Stars light up. Supernovae and black holes stir and heat the gas. Winds blow. Disks thicken. Bars form. The details are messy and alive, but the bones are always the same. Dark matter provides the framework upon which the luminous world is hung. It is tempting to hope for an escape hatch. Perhaps gravity does something different at very low accelerations. Perhaps our equations need a gentle bend. Modified Newtonian dynamics and its relativistic cousins tried to write such bends into the rules, and in some galaxies the fits are elegant. But on larger scales, clusters like Coma, colliding clusters like the Bullet, the lensing maps that drape arcs across the sky, the growth of structure from the microwave background to the present, the stolen gravity from a modification alone, struggles to speak every dialect at once. Dark matter, for all its stubborn refusal to be seen, gives a fluent account across scales, with one principle: add mass where the light is thin and the paths fall into place. The numbers are plain and humbling. By the best measures, the universe's energy budget is dominated by things we cannot hold. Roughly 68% is dark energy, a smooth pressure that speeds expansion. About 27% is dark matter, the silent weight in which galaxies are wrapped. A narrow slice, about 5%, is ordinary matter, the atoms that make stars and salts and skin. Of that small slice, only a fraction shines. The rest is gas warmed between galaxies, dust drifting in disks, cold clouds where stars may yet be born. Everything you have ever touched is a sliver of a sliver, and still it is enough to write poems and cultivate gardens. Bring it closer to the home you can name. The sun circles the center of the Milky Way at about 514,000 miles per hour, and a full lap takes on the order of 230 million years. If only the stars and gas in the disk weighed on the sun's path, that speed would be reckless. But the halo softens the verdict. Extend the mass well out past the visible disk. 200,000 light-years is a common estimate, and the arithmetic becomes generous. The sun's race is a glide. The stars at the edge are not misbehaving. They are simply following a curve drawn by matter we cannot see. Lensing confirms that curve far beyond our neighborhood. Euclid, launched to map weak lensing across billions of galaxies, will chart how the cosmic web has grown. The Nancy Grace Roman Space Telescope will join that work, widening and deepening our maps. Together, these surveys aim not only to weigh where the dark matter lives, but also to watch how it and dark energy play their tug-of-war over time. Meanwhile, the James Webb Space Telescope reaches back to when the first substantial galaxies were assembling, less than 400 million years after the beginning. Even then, many look organized, their stars moving in ways that suggest steady rotation. That early order hints that halos were already present, guiding the light into disks before the universe had much time to practice. Dark matter's touch shows up in places that feel far removed from grand clusters. In small galaxies where the luminous mass is meager, the unseen dominates. Their stars move as if cushioned by a gentle, round well that extends beyond the faint fuzz we can photograph. In galaxy pairs and groups, orbits and tails, those long, gauzy streams pulled out by tides carry the accounting of momentum and mass. The tails are often made of ordinary matter and glow. The halos are invisible, but their gravity decides how the tails arc and where the remnants will settle. There is poetry in the plainness. Dark matter does not need to be elaborate to be essential. It does not collide or clump into atoms. It does not form molecules or clouds that spark stars. It does not ignite or cast shadows. It simply adds weight in the right places, early and everywhere. Without it, the early universe's gas would not have gathered quickly. It would have stayed too smooth for too long. With it, the first bright things could kindle while the universe was still young. And yet the mystery remains open in the most important way. We do not know what dark matter is. We can map where it must be. We can feel its pull through the arcs it draws, across images and the speeds it permits in disks. We can simulate its part in building the structures we live inside. We can test ideas that change gravity's rules and see where they falter and where they match. We can cool detectors to near silence and wait for a rare tap. We can look to the hearts of galaxies for gamma-ray signatures that never quite rise above the noise. But the particle or family of particles has not stepped forward with a confession. This is not a failure. It is the deep pace of patient science. The universe does not owe us haste. For now, the best picture is both modest and grand. Modest because it says only, add a component that gravitates, that was present early, that interacts weakly with itself and with ordinary matter, and distributed in halos around and among galaxies. Grand because on that modest addition rides almost everything we see. The way spiral arms hold together, the way clusters bind, the way the cosmic web grows and curls. The subtle hush of gravitational time delays in multiply-lensed quasars, the slow fall of a satellite galaxy into a parent's halo, shedding stars like sparks along a dark river. The universe's structures are not floating on nothing. They are perched on a framework that does not glow. It can feel strange to live in a world so thin compared to what surrounds it. But there is a comfort in the thought that stability can be provided by something that does not clamor for attention. Bridges often rely on cables you never notice if you only look at the roadway. Cathedrals stand because of arches that direct weight into stones that do not shine. Galaxies spin and do not fly apart because an invisible architecture bears their motion without complaint. Hold the thought gently. Every star you have ever watched rise is moving in a curve written by a hand you cannot see. Every faint smudge in a telescope, the little whirlpools of light that are towns in the night, sits inside a halo whose only language is gravity. Even the empty places between clusters are shaped by the tension between dark matter's pull and dark energy's push. A quiet contest that decides how fast structures grow and how widely they spread. There is a softer question hiding at the edge of this. If the same unseen scaffolding steadies galaxies and gathers them along filaments, could it have also nudged the paths of smaller things? Dust, grains in early clouds, icy seeds in protoplanetary disks? The chemistry that learned to prefer one hand over another? The forces are different, the scales far apart, and yet the theme is familiar. An invisible preference setting the stage for what can last. Whether or not dark matter touched the direction of life's spirals, it certainly made a universe where spirals could endure, where disks could settle, arms could hold, and a planet could keep a long, even day. In that sense, the unseen weight does more than keep galaxies whole. It keeps the night full of shapes that feel like home, and it leaves room for quieter mysteries to find their turn. Every living thing carries a quiet swirl. The double helix folds to the right, like a staircase, turning toward morning. The amino acids that knit your muscles and shape your enzymes lean left, each one a tiny preference held with conviction. This one-sidedness chirality isn't a footnote in biology, it's a cornerstone. It says that life did not choose from two identical doors. It walked through one, closed it gently behind, and has been moving forward with that same turn ever since. Hold one hand over the other and you'll see the idea. Left and right match in outline, but won't lie on top of each other, palm to palm. Many molecules behave the same way. Chemistry, when left to itself, often makes both versions at once, mirror images born in equal numbers, but life refuses the tie. DNA and RNA win right. Proteins are built from left-handed amino acids. Sugars in your cells are almost exclusively right-handed. This preference runs so deep that reversing it would break the choreography that keeps you alive. Some reactions would slow or fail. Some locks would no longer fit their keys. If chemistry is ambidextrous, something outside the beaker must have nudged the balance before biology learned to hold it. One candidate is light, the earliest, hardest light from massive newborn stars, filtered through magnetic dust and made to prefer a twist. Light can carry polarization, a kind of handedness in its oscillation. When that polarization is circular, photons have angular momentum. They are, in a sense, spinning. In clouds where stars are born, grains of dust align with magnetic fields. Those fields can be shaped and twisted by large-scale motions in galaxies. Starlight scattered through such grains can become circularly polarized. If that light bathes simple prebiotic molecules, it can ever so slightly favor breaking one mirror form more than the other. Over long times, a hair's breadth becomes a habit. Hints come from places older than oceans. When a small comet was visited and sampled, its chemistry was not blank. It carried organic building blocks, including precursors to amino acids. Meteorites that fell to Earth like the famous Murchison stone were found to contain dozens of amino acids, with a faint but real excess of left-handed forms in some classes. Those rocks remember a time before Earth had seasons, when the solar system was a cold disk of dust and ice. Their bias suggests that the thumb on life's scale may have pressed down during interstellar chemistry, long before a living cell had the power to choose. Chirality doesn't stop at molecules. It echoes across scales in ways that are easy to notice once you know how to look. Storms spiral differently north and south of the equator because a turning planet persuades moving air to curl. Shells grow in spirals that often favor a direction, a pattern embedded in the way crystals assemble and tissues lay themselves down. Even a sunflower head, if you count carefully, hides spirals that prefer one direction more often than chance would demand. None of these phenomena causes life's molecular handedness, but they rhyme with it. They are small reminders that nature is comfortable with bias when conditions invite it. The deeper clue is older than shells and storms. In the realm of particles, the universe has already declared a preference. Neutrinos, ghost-like, nearly massless, come to us left-handed. Their mirror partners do not show up in the same way. The weak nuclear force, responsible for certain forms of radioactive decay, treats left and right differently. In a celebrated winter experiment, cobalt nuclei were cooled and aligned, and the direction of emitted electrons betrayed a bias. Nature's bookkeeping for that interaction violates simple mirror symmetry. The result wasn't a flourish, it was a fact. Some laws do not look the same in a mirror. You don't need to know the math to hear the implication. If, at the root, some interactions prefer a hand, it's less surprising that chemistry might inherit a slant. The path from a particle's parity violation to a living cell's chirality isn't a straight road. It wanders through the dust of star-forming regions, the icy mantles of grains, the slow cooking in protoplanetary disks. Yet the signposts point in a consistent direction. Asymmetry exists in the foundations. It does not have to be invented later. Think again of light, not as brightness, but as behavior. Photons can be left circularly polarized or right circularly polarized, and in some environments, one dominates an imbalance set by fields and geometry. Laboratory work has tried to mimic what the interstellar medium does at a slower pace and in miniature. Bathe racemic mixtures of amino acid precursors in circularly polarized ultraviolet light and watch a tiny excess emerge. It isn't dramatic. It doesn't leap from zero to perfection. But life did not need a leap at the start. It needed a seed of preference, small enough to slip through the chaos and big enough to be amplified by cycles, evaporation and condensation on grains, adsorption and shock waves in clouds, the traffic of molecules on early mineral surfaces. Once the slightest tilt appeared, catalysts could lock it in. Certain crystals favor one hand's attachment over the others. Clays can select and pre-concentrate. On a warm world with shorelines and tides, wetting and drying can enrich a bias further. A tiny initial asymmetry becomes a pattern strong enough to survive noise. When replication enters the picture, when strands can copy strands, when enzymes fold with exquisite specificity, the die is cast. Right-handed sugars pair naturally with bases that stack into right-twisting helices. Left-handed amino acids fold into proteins whose grooves and pockets fit the shapes they encounter. Flip the entire system and, in theory, you could build a mirror life, but you cannot flip it piecemeal. One wrong hand in a sea of the opposite won't fit the locks that evolution already made. There is a softer, structural harmony in the choices we ended up with. A right-twisted backbone like DNA's pairs well with left-handed amino acids, building proteins that recognize that twist without confusion. The complements are more than aesthetic. They make molecular meetings efficient. Biology is full of these fits. Enzymes meeting substrates, receptors greeting signals, ribosomes reading strands. A universe that left room for such fits had to provide consistent preferences early enough that complexity could build on them without slipping. If you stand far back beyond cells, beyond storms, beyond the little lives of planets and the slow lives of stars, you can ask whether the largest patterns in the universe also prefer a hand. Surveys of galaxy spins have sometimes reported mild imbalances in clockwise versus counterclockwise orientations across large patches of sky. The results are debated, the difference is small, the methods delicate. But even the asking feels of a piece with everything else. Is there one more echo of a primordial preference? If a faint tilt existed in initial conditions, would it ripple outward to scales so large we can only sense it by counting millions of swirls? It is easy to overreach. The handedness of a hurricane is set by a rotating Earth and the geometry of latitude. Its sense swaps across the equator. The chirality of molecules is set by intimate interactions of electrons, nuclei, light, and fields. These are not the same mechanisms wearing different costumes, yet they live in the same family of ideas. When symmetry is perfect, nothing happens. When symmetry breaks, patterns appear. The universe, from its first hot fractions of a second, has been a long education in how to use small asymmetries to build large structures. Direction does not come from nowhere. It is chosen by conditions, stone by stone, and then inherited. Look to the star nurseries, where new chemistry is written. In cold, dense regions of the Taurus, dark clouds or the lanes of Orion, infrared eyes now see carbon chains, nitriles, simple sugars, and ring structures on the way to complexity. Some of the light we collect there is polarized by aligned dust. Some of the absorption features suggest ordered steps toward prebiotic molecules. The environment is not sterile. It is biased by fields and flows, by shocks and the slow drift of grains that remember their spins. In such a place, handedness doesn't need to be imposed. It can arise from the way light arrives and the way surfaces present their faces. Meteorites that carry a chiral slant don't prove the whole story, but they ground it. They fell into a landscape already alive, but they were made when alive had not yet been invented. The left-leaning imprint inside them says that directionality can be older than Darwin, older than oceans, older than weather. Comets that keep fragile organics through the cold say that space is not a desert where chemistry falls apart. It is a workshop where long patience makes tiny choices durable. Nothing about this demands that the universe itself whirl like a top and dictate a single cosmic left. It asks only that motion and fields and light, born from early asymmetries, create local preferences again and again, at scales small enough to matter. A galaxy's rotation does not twist a molecule directly. The chain of causes is longer and gentler. Galactic motion helps align dust and shape magnetic fields. Those fields polarize light. That light, following the rules of interaction, shaves a fraction of one mirror form away. With time and cycles, the fraction becomes a fate. There is kindness in how small the necessary push can be. Chirality is a switch that wants to snap to a side once the hinge starts to move. An excess of 1 part in 10,000, maintained across cycles, can snowball into purity. Once life begins, feedback loops take over. A left-handed amino acid can catalyze the formation of more left-handed amino acids. Right-handed sugars help make right-handed sugars. The ladder climbs itself, rung by rung, and soon the whole edifice leans with confidence. The opposite choice would have worked, too, if the earliest nudges had reversed. The important thing is not which hand won, but that a single hand was chosen so everything could interlock. This, perhaps, is the quiet answer to the question of whether the universe's spin decides the direction of life. Not decides like an order, but suggests like a wind. The first motions, fields curling, dust aligning. Light learning a preference made it easier for one hand to survive. Quantum rules ensured that left and right were not treated as identical in every interaction. Chemistry took those influences and built them into selections. Biology turned selections into necessity. Across billions of years, the same whisper has been amplified until you can hold it between your thumb and forefinger and feel its consequences in the twist of a strand. You are made of these whispers. Every cell in you contains DNA that turns the same way. Every protein you build folds from left-handed amino acids that found their advantage long before tide pools gurgled. The breath you take moves through a body whose sense of time, sleep, and waking, hunger and satiety was tuned on a spinning world that teaches even larger lessons about direction. In the same sky, galaxies carry their light in arms that curl, sometimes one way, sometimes the other, their motions held together by scaffolding you cannot see, but can infer by how they keep from flying apart. Preference is not a flaw, it is how the world composes. If you want a few anchors to keep in your pocket, they can be small. Neutrinos favor left. The weak force violates mirror symmetry. Many meteorites bring a slight excess of left-handed amino acids. Light, when filtered through dust and fields, can be polarized in a way that acts differently on mirror molecules. Star-forming regions host prebiotic chemistry in the glare of polarized starlight. On Earth, enzymes and receptors are so particular about handedness that the wrong mirror form of a drug can fail to bind or cause harm. Biology is a library of fits, and chirality is the cataloging system. The rest is tenderness more than theory. The swirl that holds galaxies together did not reach into a cell and twist a helix, but it did make a universe rich in aligned grains and favored light, rich in the kind of environments where a coin tossed many times finally lands the same way enough for luck to become law. Direction came from motion and became memory. When you picture the Milky Way glowing as a slow pinwheel, you can let the image echo inward until it becomes a tiny staircase inside a single nucleus in a single cell. The shapes are different, the causes distinct, but the habit of choosing and keeping aside connects them. If someday we find life elsewhere and it winds the other way, left-handed DNA, right-handed amino acids, it won't undo the story, it will confirm it. Local conditions can tip the first stones. Evolution will do the rest. The universe provides the bias. Life provides the commitment. On some worlds, the wind may blow from the other shore. For now, it is enough to notice that you are full of spirals, and those spirals are not arbitrary. They are fossil records of nudges that began before Earth existed. In them is written the patient connection between motion and preference, between fields and forms, between a sky that never stops turning and a strand that never unwinds the wrong way. Take the thought with you into the hush of night. You are part of a continuity that begins in polarized light and ends in a heartbeat. And if everything that turns carries the seed of slowing, if even stars spend their spins and galaxies trade their angular momentum in long mergers, it's natural to wonder what happens when the big motions tire, when, after so much coiling and uncoiling, the great fabric forgets how to keep the curls. Every rotation carries its own tenderness, and every turn, no matter how steady, leaks a little of itself into the world around it. What begins as a confident spin becomes a softer rhythm, then a sway, then a memory. You can see it in the day itself, the length of sunlight creeping by imperceptible measures as the Earth gives up a sliver of speed to the moon. Each century, tides reach up, take hold, and tug about 1.7 milliseconds added to the day. Hardly enough to trouble a clock, yet enough to mark that nothing that turns can keep its pace forever. The energy of the spin isn't lost, it is traded outward. The moon receives the payment and drifts away, roughly 1.5 inches each year, a quiet parting measured to millimeters by the laser echoes still returning from mirrors left in the lunar dust. The same surface that once lifted oceans into long, shining arcs now eases toward a future where day and tide will settle into a single shared rhythm, two faces kept, two faces shown, a duet without crescendo. Elsewhere, the lesson repeats, each world telling it in its own accent. Mercury, nearest the sun, is caught in a 3-to-2 entanglement, 3 turns for every 2 laps, its rotation and orbit locked by the sun's relentless pull. Venus leans against the rule, with a slow, backward spin that takes about 243 Earth days to complete, its dense air brushing the surface and turning the planet's day into a drawn-out exhale. Mars, so like us in the length of its day, still yields, little by little, to the frictions and exchanges that smooth motion toward repose. Over spans longer than language, spins wind down, not to nothing, but to balance. Pull back, and the same patience plays across the plains of galaxies. The distant spirals in deep images, small, bright pinwheels from a younger universe, often show the tight arms and energetic rotation of a fresher time. Closer to us in cosmic age, many disks look broader, calmer, their stars circling in paths shaped not only by the mass of what shines, but by encounters and mergers that reroute angular momentum outward. When 2 galaxies meet, their stars mostly slide past each other, missing by light years, yet their halos embrace, tides pull, and the overall spin is shuffled and shared. The sharp pattern of a spiral can soften, rounds can swell, and by the end of a long embrace, an elliptical remnant may glow, its internal motions still rich, but less a single turn and more a complicated drift of orbits in all directions. Our own home will learn that language. The Milky Way and Andromeda are on course for a meeting measured in billions of years. The approach won't be a crash so much as a weaving. Streams of stars will draw out like silk, loops will fold back, and the central light will thicken. Whatever rotational grace remains will be held in a new, broader figure, the signature of 2 histories made one. The night sky will change its script, and then, after a time longer than continents remember, it will settle again. Even when a life ends in fire, the story of spin bends, it doesn't break. A massive star that collapses pours its size inward and keeps its angular momentum. Smaller means faster. The result can be a neutron star, a city-wide sphere dense beyond analogy, whirling hundreds of times each second. Some sweep beams of radiation like lighthouses, the rhythm so precise that it can teach a metronome humility. Instruments peering from orbit, listening for soft X-rays, have timed one such heart at about 716 rotations per second. The speed is astonishing, but even there, the ledger is strict. Magnetic fields and winds sap energy. Tiny ripples in space-time, the gravitational waves that carry away whispers of motion, steal a fraction more. The pulse slows, not in sadness, but in order. Black holes take the logic to its edge. A rotating black hole stores angular momentum in a way that reshapes the space-time around it, and the spin can, in principle, be drawn down by interactions with light, matter, or space-time itself. Over unfathomable times, even a black hole radiates Hawking's insight that the horizon is not a perfect one-way skin. The losses are delicate and desperately slow for large holes, but they point to an ending that is not a wall, only a thinning. A merging pair rings space like a struck bell, and the ringdown sends a part of their spin outward as waves. Future instruments, floating in deep silence between worlds, will feel these tremors and write down their cadences, records of rotation being spent into the fabric like dye into water. What then of the long fate people call heat death, the era when gradients are gone and the universe is smooth the way an old stone is smooth? Angular momentum is conserved. It does not vanish any more than energy vanishes. But conservation doesn't forbid dispersal. Motion can be shared so widely among so many by so little that it becomes invisible to anything short of perfect arithmetic. In that late age, orbits loosen into drifts, structures relax, and what remains of spin is everywhere and nowhere at once, present as a number that balances, absent as a rhythm you can stand inside and feel. Rotation persists in principle, but with no contrast to illuminate it. It is like a song spread over a silence so vast that no ear can call it music. Between our nights and that far hush lies a long corridor of transformations. Planetary days lengthen, tides soften, rings erase themselves into moons or fall as rain of ice. Stars spend the last of their nuclear stores and cool into embers that themselves cool further. Galaxy pairs knit into larger families and then slowly forget their original shapes. Collisions become rarer as expansion stretches distance. The bright hubs of clusters keep their local conversations, but the dialogue across the wider web grows thin. Everywhere, spin becomes a record rather than a performance, encoded in the alignments of orbits, in the polarization of ancient light, in the geometry near the remnants of once violent hearts. It helps to remember that the unwinding is not a betrayal of beginnings, but their completion. The same rules that took quantum jitters and amplified them into motion also insist that motion be shared and softened when nothing stands against that sharing. Tides are simply gravity's way of evening out a difference. Magnetic braking is the price a rotating field pays for lighting up its surroundings. Gravitational waves are the fair tax of a lopsided mass on the medium it disturbs. Each mechanism is a kindness of the laws, no hoarding, only exchange. And yet, tonight, the world still turns with ample grace. The day is still near 24 hours long. The moon still stages tides twice a day that pry at continents and comb the shores. The sun still keeps time at the Milky Way's pace, circling the center in a span that makes geology feel young. Pulsars still beat, black holes still wind and unwound, clusters still lens the light of galaxies behind them into arcs that tell us where the hidden mass rests. The evidence of motion is everywhere if you look with the right instruments, and the instruments are, in a way, our promise to the future that we noticed. The dispersal of spin does not erase its fingerprints. The cosmic microwave background still carries a map of early motion, a faint mottling, a subtle polarization that speaks of stretching and curling in the first instance. The arcs and smears in lensed images trace the invisible wells that held galaxies together when they might have flown apart. The delays in the echoes of X-rays near black holes draw the outlines of orbits light itself had to take. In these signs, motion remains legible, even as the motions themselves bleed into broader seas. If there is melancholy in the idea of a universe easing towards silence, there is also relief. Balance has its own peace. The blaze of beginnings is not the only kind of beauty. The coolness of completion is a beauty as well. The path between is where we live, and it is rich with structure, storms, Seasons, rings, disks, webs, all of them transient, and all of them generous with meaning. Conservation offers the final word. Angular momentum can be traded, reshaped, radiated, but not destroyed. The universe does not forget how to spin so much as it forgets how to keep spin in one place, in one pattern, with one strength. What we call unwinding is a million small sharings, the angerless diffusion of motion into more and more degrees of freedom. There comes a time, if the predictions hold, when the sharing is so complete that no wheel stands out from the stillness. No orbit holds a margin over its neighbors. No clock can be built from contrasts that no longer exist. But even then, the equations would remember. Geometry would carry the ledger. The last photons and neutrinos would drift on with phases and momenta that add up to the same old total. Until that horizon, we keep to our scale. The core of the Earth still turns. Magnetic lines still rise and fold. The atmosphere still coils and uncoils its long bands of wind. The galaxy still keeps its course through the local gravity that binds our cluster. Somewhere, something just merged and sent a shiver across space-time. Somewhere else, a neutron star's pulse clicked once more. Each is a small proof that the old rotation goes on, thinner in some places, stronger in others, patient everywhere. So will the universe forget how to spin? Not in the way a mind forgets a name. More like a story retold so often that the details spread out and soften until only a mood remains. A feeling that something once moved here and left the room gentler than it found it. Motion doesn't vanish, it learns to be subtle. And we, living in the bright middle, are made of that motion and tuned to it, the length of our days, the way our hearts measure rest and waking, the orbits of our thoughts around what matters. All of it is a local translation of a very old turn. If you listen, you can hear the quiet hum of a world still spinning, a star still circling, a galaxy still drifting among companions. The hum will not last forever, but it will last long enough to make meaning, long enough to raise questions and cradle answers and carry them forward. When the hum is gone, the record will remain. Not movement, but the memory of movement, the curves inscribed in light, the alignments that refuse to randomize even when the lights are low. And if there is a softness to that ending, there is also a softness to this moment, a universe still turning, still sharing, still writing time in circles that, for now, we can feel. There's a small, steady whirl inside everything that belongs to you. Not the rushing kind, not dramatic, just a poised, ongoing turn. Electrons carry intrinsic spin. Nuclei hold their own subtle orientations. Fields couple and uncouple in patterns that remember how to move. None of it is random noise. It's a continuation, threads of motion, reaching back to the first light, the first gradients, the first places where symmetry loosened enough for a direction to exist. When you lift a hand, when a thought gathers and crosses your mind, you're not apart from that story. You're written in its ink. Motion isn't happening out there while you stand still. It's the quiet memory the universe keeps moving through you. Angular momentum is the soft law behind this faithfulness. It says that turning persists unless persuaded otherwise. And if persuaded, the turning is shared rather than destroyed. That's why clouds shrinking into stars wind themselves up. It's why newborn disks lay rings of gas and dust that grow into families of worlds. It's why a galaxy's outskirts can keep pace with its heart. The same grammar is smaller, too. Quantum spin sets how electrons arrange, how bonds are possible, how matter holds shape. Chemistry, biology, weather orbits different scales of the same habit of keeping a direction once it's begun. If there is a cradle for memory in physics, it is any arrangement that can preserve a pattern. At the tiniest scale, a spin orientation acts like a bit that resists easy erasure. In a cell, a folded protein holds a shape and shares it by guiding partners towards similar folds. In a brain, pulses ride along membranes, begin in one cluster and end in another, and the strength of the path changes with use. None of these are mystical. They're arrangements that endure long enough to be called remembering, and each arrangement is, at bottom, an economy of motion: how charges move, how ions pass, how fields align and relax, how a small turn whispers to the next small turn and nudges it into agreement. Space-time itself isn't a passive page for these stories. Heavy, spinning things write curls into it. Nearby, paths bend by imperceptible amounts. Farther away, the ledger still balances. That twist frame dragging was measured around Earth, with gyroscopes built to hear the faintest tug. Even our planet, modest and slow compared to a collapsed star, pulls time and space into a subtle swirl as it turns. The same rule is fiercer near compact objects. There, time slackens and directions are braided together. Light hesitates in shallow orbits before it can leave. None of this says awareness floats on top of physics. It says awareness is what it feels like from the inside, when matter and fields maintain patterns richly enough to model themselves. Think of light as part of this memory rather than just illumination. Photons carry spin and polarization, a small but exact signature of how they were made and what they crossed to reach you. Some were born in the glare of stars and scattered through aligned dust, inheriting a preference on the way. Some left the early universe when it became transparent and have been traveling ever since, their colors stretched, their polarization faintly curled by old waves in space-time. You don't have to memorize the names carved on these maps to understand the point. The sky is full of signals carrying the handwriting of motion. When that light meets the layers of molecules in your eye, it starts other motions, other memories. Sensation is not a separate kingdom, it's a relay. The same relay is everywhere in you. Neurons are tiny conduits for moving charge. Glia shift ions and support the timing that lets signals arrive together instead of smearing into static. A heartbeat is a tissue-level oscillation made from microscopic shifts of ions through channels whose shapes exist because electrons have spins and shells and rules. Even sleep, a savored stillness, has rhythms whose periods are anchored, in the widest sense, to a turning world and a turning sky. The feel of being you is stitched from motions that learn to repeat. It can be tempting to draw a straight line from the first moment of the universe to the present and say, this spin became that thought. The truth is gentler. There were many steps, fluctuations spread by expansion, gravity finding seams to gather, disks learning to roll, fields choosing alignments that made chemistry hospitable, molecules discovering ways to copy, cells rehearsing until memory became reliable, tissues developing conversations broad enough to be called minds. At each step, motion wasn't invented anew, it was reorganized. Some of it was guided by conservation, some by geometry, some by sheer survival. The patterns that persisted were the ones that could maintain their movement in a noisy world. If the universe remembers, it isn't because a grand ledger sits somewhere with perfect ink. It's because the rules favor persistence and sharing. Angular momentum doesn't vanish. it migrates. Energy doesn't disappear, it disperses. Geometries retain the faint curls of what once turned inside them. Minerals keep fields frozen into their grains from ancient storms in Earth's core. Meteorites bring a bias born under polarized starlight to a warm coast and tip a balance. A ring around a planet records collisions too small for any eye to see. Its gaps and waves are the memory of many gentle meetings. Patterns remain and become the seed for the next pattern. Over time, the world looks like a palimpsest. Old motion rubbed thin, new motion written on top, both legible if you know how to look. You can carry this close without turning it into a weight. The motion you keep isn't a task, it's a gift already given. When you place a hand on a table and feel the grain, you're touching arrangements made by electrons that refuse certain positions and prefer others because of spin. When you listen for a distant train at night and hear the rise and fall of pitch, your ear and brain perform a tiny physics of waves and timing. When you remember a name, you're not summoning a ghost, you're reactivating a path, strengthening a pattern that was laid down by earlier activity. In all of these, the universe isn't admiring itself in a mirror, it's being continuous, and continuity looks like memory from the inside. There are days when the sky feels indifferent, cold, light, long distances, a sense that human scale barely registers. It helps then to reverse the gaze for a moment. If a galaxy's rotation curve is a record of how unseen matter holds it together, your breath is a record of how trillions of coordinated motions welcome oxygen and share it. If a black hole's ring down is a song of energy being let back into the world, your laughter is a small, bright release of stored patterns into sound. No equivalence in size is claimed, only kinship in kind. And there is comfort in knowing the remembering doesn't require permanence. Nothing you are is everlasting in isolation, but the ways you move your care, your attention, the choices that become habits fold into other lives. They change timings, reprioritize signals, adjust which patterns are likely to be rehearsed again. Memory, in this larger sense, is distributed. It is not a vault, it is a current. The universe's memory of motion flows through families, cultures, forests, oceans, cities. It leaves traces in language, in music, in the quiet competence of hands. It leaves traces in instruments that will keep listening after we are gone. Radio dishes, mirrors on mountaintops, clocks that count with the patience of atoms. If all of this sounds like a circle, that may be because a circle is the most honest shape we have for it. Motion gives rise to structure. Structure sustains motion. Sustained motion becomes memory. Memory invites awareness. Awareness chooses and sets new motions in place. You are somewhere in the circle tonight, not at the center, not at the edge, but on the path itself. The universe does not need you to remember for it, and yet, through you, it does. You notice, you carry, you pass on. So, are you the universe remembering its own motion? In the most literal, quiet way, yes. Not as a slogan, but as a fact of continuity. The spins that keep atoms possible are part of you. The orbits whose steadiness lets calendars exist. Mark your days. The curls, written into space-time by turning bodies, pass through you and add up with everything else to make your now. Awareness is what it feels like when patterns of motion become rich enough to model themselves, keep themselves, and wonder, gently, how long the keeping will last. Let that be simple tonight. The world turns, the galaxy drifts, old light arrives with its long story. Lungs fill and empty. A thought crosses the room and takes a seat. None of it stands apart. All of it is the same inheritance, moving through different rooms. If you ever need a small anchor, this can be one. You are not separate from the motion that made you. You are its living continuity, its soft-spoken memory, its way of knowing, just for a while, how it feels to keep turning.